Hello, before I reopen the MT6 affirmation for you, I want to go over a few of them with you. This question right here, is this a parallelogram? Well, obviously, if I'm going over it, it probably is, but why is it? Well, if we take a look at angle ACB and angle CBD, those two angles are congruent. They're alternate interior angles, so that makes the side BD parallel to side AC. So we got one set of parallel sides. Now we're told angle DBA is congruent to DCA, the entire angle, the big angles. Well, we already know the other pair of angles. So what does that tell us? Well, that tells us that angle CBA, this angle right here, is congruent to angle DCB, this angle right here, by the angle addition property. And therefore, we know these two sets of sides are parallel. So that makes this shape a parallelogram. Okay, let's do a little review of our Venn diagram from your assignment, and actually we had a question like this on your affirmation. So this is the set of all quadrilaterals. Some of those quadrilaterals are rectangles. Some of those quadrilaterals are rhombi. If a shape is both a rectangle and a rhombus, it's a square. And then we had trapezoids over here. But I don't think that affects this problem. Every square is a rectangle. Yes, every square is a rectangle because it's inside the rectangle. Every rhombus is a rectangle. Nope, only some of them are. Every quadrilateral is a rectangle. No, we have some quadrilaterals that are not rectangles. So that one's false. Every rhombus with 4 right angles is a square. Well, a rhombus has 4 equal sides, so if it has 4 right angles, it is a square, so that one's true. In this case, I don't want a decimal approximation. And from the first chapter, distance cannot be negative. That was the key on this one. I think you had a negative answer for one of these. So let's find the length of GH. Well, remember, distance is you subtract the x's and square them. Subtract the y's and square them. Add them together and take the square root. So we're going to look at G, which is -4, and H. So if we do our work here, I think you had this one right. So -1 minus -4 squared plus -5 minus -4 squared. Well, -1 minus the -4 is -1 plus 4, so that's 3 squared. -5 plus -4 is -1 squared. We square that, we get 9 plus 1, which is the square root of 10. Now let's do the same thing for J to K. Just change colors here, but we use the same formula. So we're going to say -2 minus 1 squared plus 3 minus 2 squared. Well, that's negative 3 squared plus 1 squared, which is 9 plus 1, which is the square root of 10. In other words, they're equal. Now let's find the slope of g to h, which we've kind of did when we did distance form, but I'll just go through it again. So remember, slope is y2 minus y1 over x2 minus x1. So to find the slope of g to h, we're going to say negative 5 minus a negative 4 all over negative 1 minus a negative 4. Well, negative 5 plus 4 is negative 1. Negative 1 plus 4 is 3, so you get a negative 1/3 for a slope. We'll do the same thing for j to k. I think I'll write it over to the side here. So 3 minus 2 all over negative 2 minus 1. 3 minus 2 is 1. Negative 2 minus 1 is negative 3, so you get negative 1/3. You have one set of sides, both parallel and congruent, so that makes it a parallelogram. So that's our first choice here. Each exterior angle of a regular hexagon. Now we know the sum of exterior angles of any polygon is always 360. Well, since there are 6 sides to a hexagon, I take 360 divided by 6. That gives me 60 degrees. That's all you have to do. That's from your formula sheet. Okay, we're going to kind of do the same thing, except they did throw a little kink at you. It's not opposite this time, it's adjacent. So we want the one next to. But we start here with the slope of GH. So let me highlight GH here so we know which ones we're working with. So to find the slope of G to H, we're going to go negative 1 minus 4 all over negative 1 minus a negative 4. Well, negative 1 minus 4 is negative 5. Negative 1 plus 4 is 3, so you get negative 5/3 for the slope. Now we want to do the slope adjacent to GH. Well, adjacent means next to, so I could do GK or I could do HJ. It doesn't matter. I think I'm going to do HJ. So I'm going to delete that. And I'm going to highlight H and J. Now we're going to do the same thing. We're going to find the slope. So we're going to say negative 4 minus negative 1 all over 4 minus a negative 1. Well, negative 4 minus a negative 1 is negative 4 plus 1, which is negative 3. 4 plus 1 is 5, so you get negative 3/5. That's what we should have got for the adjacent to GH. Now we're going to find the length of G to H. Well, we're going to use the distance formula again. And so now, do you notice that you use slope when you do this? Because y2 minus y1, that will be negative 1 minus a negative 4 squared plus negative 1 minus 4 squared. Well, negative 1 minus a negative 4 is 3. Negative 1 minus 4 is negative 5. When you score a negative, you get a positive. I don't like the way that looks, so I'm going to rewrite that. There we go. So you get 9 plus 25, which is the square root of 34. And then the slope of adjacent to GH, well, we do the same thing, don't we? We're going to say 4 minus the negative 1 squared plus negative 4 minus the negative 1 squared. Well, that'll be 5 squared plus negative 3 squared, which is 25 plus 9, which is the square root of 34. Now we're told it's a parallelogram. Is it a rectangle? It is not a rectangle, because if it was a rectangle, these sides would be at a right angle. They'd be perpendicular to the opposite reciprocals. Notice they're reciprocals, but they're not opposite reciprocals. They're both negative. It is a rhombus because it has both sets of sides, or all sides are congruent. They're all the square root of 34. It's not a square because it's not a rectangle. In order to be a square, it has to be a rectangle and a rhombus. And there you go. Okay, the proof. You did most of the proof right. I think it was step 9 and step 11 that we need to take a look at. So we're given that angle J is congruent to angle L. We're given that angle K is congruent to angle, or is equal to angle M. I said congruent, I meant equal. We know that all the sides add up to 360. Now look at step 4. Well, step 4, there's 2 parts I go on. First off, we just changed L and M to J and K, didn't we? So we used the substitution property. I think you had that one right. And so then that equals 360 because we haven't changed anything there. Then we simplified on the next step, so it still equals 360. And then we divided both sides by 2, so that's the multiplication and division properties. That's this step right here. Now, because J and K add to 180, that makes J and K supplementary. You had that part right also. And since J and K are supplementary, that makes JM parallel to KL. Now, what happened on step 9? Notice what happens is back from step 6, I just replace K with M because I know K equals M. When we replace something with something else that's equal, that's substitution. You had a different property that didn't make any sense. That's what we needed there. And so then you had step 10, right? Which makes J and M are supplementary. Well, if J and M are supplementary, you had step 11 right too. It was step 12 I think you got wrong. You said JK is parallel to LM, which I agree with. Notice you have 2 sets of parallel lines. Opposite sides are parallel. That is the definition of a parallelogram. That's the reason we know this is a parallelogram, because it has 2 sets of opposite sides parallel. That's what we needed for step 12. Okay, I've reopened the test for you so you can finish the ones you didn't do. I didn't go over the ones you didn't do. I just went over the ones that you did and got wrong.